Imagine you're standing in the middle of the biggest piece of land that ever existed on planet Earth. Not just big, massive, gigantic beyond anything you can picture. This is Pangaea. Every continent you know today, smooshed together into one enormous landmass. North America, South America, Africa, Europe, Asia, Australia, Antarctica. All of them connected. One giant supercontinent, and you're standing right in the center of it, thousands of miles from the ocean in every direction. No lakes nearby, no rivers, just dry land stretching forever. The kind of dry where your lips crack, where nothing grows except a few tough plants here and there, where the sun beats down day after day with nowhere to hide. It's a desert, a massive, endless desert. But something's about to happen. Something that will change everything on Earth. Forever. Before we go further, let me ask you something. Where are you right now? Are you in bed in Tokyo? On a couch in Toronto? Maybe you're in Mumbai, or Mexico City, or Manchester. I make these videos for people everywhere trying to fall asleep at all different times. If this helps you relax, consider subscribing. I check the comments and I love seeing where everyone's from. Berlin at breakfast, Boston at bedtime. All at the same time. It's pretty cool. Okay, back to our desert. You're standing there in the heat. Your skin is dry. The air feels heavy. And then you notice something. A change. The temperature drops just a little. You feel it on your arms first. You look up. Dark clouds are rolling in from nowhere, in a place where clouds almost never form. Then you feel it. A drop of rain hits your face, then another, then more. Within minutes it's pouring, really pouring. The kind of rain that soaks you in seconds, that turns dust into mud, that makes you think, wow, this desert really needed this. But here's where it gets strange. The rain doesn't stop. Not after an hour, not after a day, not after a week, not after a month, not after a year. This rain keeps falling for over 1 million years. Let me say that again, because it sounds impossible. 1 million years of rain. Continuous rain. Just falling and falling and falling. How is that even possible? What could make it rain for 1 million years straight? What does that do to a planet? Well, it does something incredible. This million-year storm didn't just water the plants, it completely changed Earth. It transformed the landscape, it killed off countless species. And it created the perfect conditions for a group of small, unimportant creatures to take over the entire world. Those creatures were dinosaurs. Without this rain, there would be no T-Rex, no Brachiosaurus, no Velociraptors, no Jurassic Park movies, nothing. This rain made the age of dinosaurs possible, and the story of how it happened is absolutely wild. Let me take you back to the beginning, back to 230 million years ago, to something scientists call the Carnian Pluvial episode. I know, boring name, right? Scientists always give the coolest events the most boring names. The Carnian Pluvial episode sounds like something you'd fall asleep reading in a textbook. But trust me, this thing was incredible. Picture Pangaea again. This supercontinent was so huge it made every continent today look tiny. If you stood on the coast and tried to walk to the other side, it would take you years, maybe decades if you're being realistic. And the middle, that interior area far from the ocean, completely dry. When you're thousands of miles from water, no moisture reaches you. The coast might get some rain, but the center, bone dry for millions of years. Only the toughest creatures could survive there. Animals that needed almost no water. Plants with deep roots searching for any underground moisture. Insects that could handle the heat. Evolution was creating species perfectly designed for desert life, and they were doing fine, thriving even. Giant millipedes crawled across the sand. Dragonflies hunted near the few water sources. Spiders built webs in the rocks. Early reptiles searched for prey in the cooler parts of the day. And there was another group just starting to appear, a group that would become very important to our story. They're called archosaurs. You might not know that name, but you know what came from them. Crocodiles are archosaurs, birds are archosaurs, and eventually dinosaurs would come from this group too. But at this point in the story, 230 million years ago, dinosaurs were nobody. They were small, not impressive, definitely not in charge. They were just trying to survive like everything else. The real danger was building beneath everyone's feet, deep underground, beneath the thin crust of rock that holds everything we know. Do you realize how thin Earth's crust really is? If you compared Earth to a big, thick book, all of life, everything we've ever known, exists on just one page. Just the surface of one page, actually. Everything else below is hot, molten chaos, and sometimes that chaos breaks through. Chapter 2. When the sky broke open, deep beneath the Earth's surface something was rising. Hot plumes of molten rock pushing up from the core. Massive columns of magma heating everything they touched. Think of them like underwater mushroom clouds. These huge pillars of superheated material pressing against the bottom of the crust. Pushing, searching for weak spots. Eventually they find one, and they burst through. When this happens, you don't get a normal volcano. You don't get a mountain that explodes and causes problems for a few hundred miles around. No, you get something called a flood basalt eruption, and it's on a completely different scale. These eruptions can release lava continuously for over 1 million years. 1 million years of magma just pouring out onto the surface, creating enormous formations called large igneous provinces. They're scattered all over the world today. The Siberian traps in northern Russia, the Deccan traps in western India, and the one that's going to be the star of our story, the Wrangelian Large Igneous Province, which spread across what's now Canada and Alaska. Here's what's terrifying about these eruptions. They're almost always linked to mass extinction events. Most of the time when one of these things goes off, it's absolutely catastrophic for life. The most famous example is called the Great Dying, the Permian-Triassic extinction event. Over 90% of all species on Earth just got wiped out. Gone. The ocean temperatures rose to 40 degrees Celsius. That's 104 degrees Fahrenheit. That's hot tub water. Imagine the entire ocean turning into a hot tub. Almost nothing could survive. It was the closest life on Earth has ever come to being completely extinguished. The planet almost became a dead rock floating in space. So when scientists see evidence of a massive flood basalt eruption in the rock record, they expect to find mass death. The two things usually go together. Huge eruption equals catastrophe. But here's where our story gets interesting. The Wrangelian eruption, the one that caused our million-year rainstorm, did cause extinctions. About 30% of ocean species died during this time. But something weird happened. Overall biodiversity on Earth didn't really decrease. In some ways, it actually increased. How does that make sense? How do you have an extinction event where diversity goes up? Well, it turns out the Wrangelian eruption was just the right size. Not too big to kill everything, not too small to cause major changes, just big enough to shake things up and create opportunities. Think of it less like an extinction and more like a massive reshuffling of the deck. Yeah, lots of species died, but lots of new species emerged, ones better suited to the new world being created. Here's what happened. The Wrangelian eruption started pumping massive amounts of carbon dioxide into the atmosphere. But it got more complicated. The magma was erupting in an area with huge deposits of coal underground. Untapped coal beds that had been sitting there for millions of years just waiting. Remember the fire triangle from school? You need 3 things for fire: fuel, heat, and oxygen. Well, when you introduce 1600 degrees Celsius magma to coal beds, you've definitely got heat, and oxygen is in the air. And coal? Coal is pure fuel, compressed plant matter from ancient forests. So the coal started burning. Massively, on a scale that's hard to imagine, and when coal burns, it releases huge amounts of carbon dioxide and other greenhouse gases, plus tons of particles that help clouds form. All of this got pumped into the atmosphere on top of what the volcano was already releasing. Observers watching from space, if there were any, would have seen carbon dioxide levels exceeding 1,000 parts per million. That's 2.5 times higher than what we have today. And this is where everything connects, because this is the same mechanism that drives climate change. When you pump greenhouse gases into the atmosphere, they trap the sun's energy. That energy can't disappear. It has to go somewhere. Where does it go? Into Earth's water cycle. Think about how the water cycle normally works. The sun heats the land and oceans. Water evaporates and rises as vapor. Wind carries it around. Eventually it cools, condenses, and falls as rain. The rain flows back to the ocean. The cycle continues. Now imagine turning up the heat on that whole system. More energy means more evaporation. More evaporation means more water in the atmosphere. More water means more clouds. More clouds mean more rain. And if you keep adding energy for long enough, the rain just keeps coming, and coming, and coming. That's exactly what happened during the Carnian Pluvial episode. But wait, I haven't told you about the really interesting part yet, the part that changed everything. Let me ask you something. Are you comfortable right now? Have you found that perfect position where you might actually fall asleep? If you're enjoying this, hit that like button. It helps other people find these videos when they need them. Alright, let's talk about what happened when the rain started falling. Chapter 3. Fire beneath the Earth. The Wrangelian eruption wasn't a quick event. It didn't just blow up one day and then stop. This thing kept going and going for over 1 million years. Imagine standing near one of these eruption sites, not close enough to die, but close enough to see it. The ground cracks open. Glowing orange magma oozes out, not exploding like a movie volcano, but flowing like a river of liquid rock. It spreads across the landscape, miles and miles of molten stone covering everything. Trees, if there are any nearby, burst into flame before the lava even reaches them. The heat is that intense, and it doesn't stop. Day after day, month after month, year after year, the lava keeps coming. It flows into valleys, fills them up, and keeps going. It creates layers upon layers of solidified rock, eventually building up formations kilometers thick. But the lava itself isn't even the main problem. It's what comes with it. Volcanic eruptions release gases. Carbon dioxide, yes, but also sulfur dioxide, hydrogen sulfide, and other nasty stuff. These gases shoot into the atmosphere in massive quantities. Sulfur dioxide combines with water in the air to create sulfuric acid. Hydrogen sulfide does the same thing. Suddenly the rain falling from the sky isn't just water, it's acidic. Not strong enough to burn your skin immediately, but acidic enough to change the chemistry of soil and water. And remember those coal beds I mentioned? The ones the magma was flowing through? Picture this. Underground coal deposits, some of them hundreds of feet thick, suddenly exposed to relentless 600-degree heat. They ignite. And coal fires, once they start, are incredibly hard to stop. Even today, there are coal fires burning underground in places like Pennsylvania that have been going for decades. They're almost impossible to put out because there's so much fuel. Now imagine that on a massive scale. Entire coal fields across what's now Canada and Alaska, burning for thousands of years, maybe longer. The smoke and gases from these fires add even more carbon dioxide to the atmosphere, even more particles for clouds to form around, even more acid rain. The atmosphere is changing fast. Scientists have found evidence of this in rocks from that time. They can measure the carbon isotope ratios and see exactly when the carbon spike happened. They can see the chemical signatures of volcanic activity and coal burning. It's all there, recorded in stone. And all of this carbon in the atmosphere, all of this greenhouse gas, it starts trapping heat. Global temperatures rise by 3 to 4 degrees Celsius. That might not sound like much, but it's enough to completely transform weather patterns worldwide. The water cycle kicks into overdrive. More heat means more evaporation from the oceans. More evaporation means more water vapor in the atmosphere. More water vapor means more clouds, and more clouds mean rain. But this isn't normal rain. This is rain on a scale the planet hasn't seen before. Clouds that would normally dump their moisture along the coast start travelling inland, farther and farther into the interior of Pangaea, into areas that haven't seen significant rainfall in millions of years, and when those clouds finally release their water, it pours. Scientists have identified 4 major pulses of rain during the Carnian Pluvial episode. 4 distinct periods where the rainfall intensified to absolutely incredible levels. Each pulse probably lasted tens or even hundreds of thousands of years. Imagine that. A rainstorm lasting 100,000 years, then easing up a bit, not stopping, just becoming slightly less intense, then ramping back up for another 100,000 years. 4 times this happened. The first pulse hit. Rain started falling in the interior deserts of Pangaea. Flash floods carved new channels. The dry soil, not used to water, couldn't absorb it fast enough. Everything washed away. Then a slight decrease. The rain continued, but not quite as heavy. Then the second pulse. Even more rain. The landscape was already soaked. Now rivers formed where none had existed. Water pooled in low areas, creating lakes and wetlands. Then another slight decrease. Then the third pulse. By now, the entire character of Pangaea's interior was changing. Desert was turning into swamp. Swamp was turning into jungle. New plant species, ones that thrived in wet conditions, were spreading rapidly. A brief decrease again. Then the fourth and most intense pulse. Over 1 million years into the event, the rain reaching areas deeper into the continent than ever before, the transformation of the planet nearly complete, and then, finally, it began to ease. Not all at once, gradually, over tens of thousands of years. The rain slowed, weather patterns began to normalize, but by then, nothing was the same. The world had been completely remade, and the creatures that survived this transformation were about to inherit the Earth. If you're still awake, that's okay. Sometimes these stories are interesting enough to keep you up a bit, but hopefully your mind is starting to drift. If you found this fascinating, consider sharing it with someone who loves dinosaur stories or Earth history. They might enjoy it too. Now, let's talk about what happened to all the living things during this million-year storm. Chapter 4. The world begins to drown. Imagine you're a species that evolved for desert life. Your body is designed to conserve every drop of water. You can go days without drinking. Your skin is thick to prevent moisture loss. You eat plants that store water in their tissues. For millions of years, your ancestors thrived in these conditions. You're perfectly adapted to this hot, dry world, and then the rain starts. At first, maybe it seems like a blessing. Water everywhere, plants growing in places they never grew before. It's easier to find food, easier to find drinking water, but the rain doesn't stop. It keeps falling, day after day, week after week, year after year. Your desert home starts changing. The temperature rises, the ground becomes waterlogged. The plants you eat start dying off, replaced by new species you've never seen before, species that love moisture. Other animals start moving in, competitors from the coastal regions where wet conditions are normal. They're better adapted to this new environment. They outcompete you for food and space. The soil chemistry changes. The acidic rain is altering the pH. Plants that could tolerate the old soil can't handle the new conditions. They die. And if the plants you eat die, you die too. This is what happened to countless species during the Carnian Pluvial episode. The old desert specialists couldn't adapt fast enough. They went extinct. We see evidence of this in the fossil record. Species that were common before the Carnian disappear from the rock layers deposited during the event. They're just gone. But while some species were dying, others were thriving. Trees were producing amber like crazy during this period, way more than normal, and that's actually a sign of stress. When trees are damaged or under environmental pressure, they produce resin as a defense mechanism. Finding massive amounts of amber from the Carnian tells us that forests were struggling. The acid rain was damaging them. The changing climate was stressing them. They were fighting to survive. But they did survive, and eventually they adapted. New types of forests emerged, different species better suited to the wetter, warmer conditions. Ferns spread rapidly. They love moisture. Conifers expanded their range. The whole composition of plant life shifted, and where plant life changed, animal life followed. Insects that depended on the old desert plants died out. But insects adapted to wet environments thrived. Dragonflies did great. They breed in water, and suddenly there was water everywhere. Their habitat was expanding massively. Other aquatic and semi-aquatic insects flourished. Beetles diversified. The insect world was being reorganized from the ground up. But the most dramatic changes were happening to larger animals. The reptiles and early mammals that dominated before the Carnian faced a choice: adapt or die. Many chose die. Not because they wanted to, but because evolution doesn't work fast enough when conditions change this rapidly. There was one group, though, that was perfectly positioned to take advantage of this new world. One group that had been waiting in the wings, just barely surviving, not particularly successful. Until now, dinosaurs. Before the Carnian, dinosaurs were basically nobody. Small, rare, not dominant in any way. They were competing with all sorts of other reptiles and early mammal relatives, and honestly, they were losing that competition. They lived in marginal environments. Places other animals didn't want, small populations scattered across Pangaea. But many early dinosaurs had one crucial advantage. They were adapted to warm, humid environments. They came from areas near the coasts or volcanic regions where moisture was available, places with dense vegetation, jungle environments. And now, suddenly, those jungle environments were spreading, rapidly, across the entire interior of Pangaea. Everywhere the rain touched, the climate shifted. Deserts turned into wetlands, wetlands turned into swamps, swamps turned into jungles, and the dinosaurs, they followed. This was their moment. Their habitat was expanding by millions of square miles, and when they moved into these newly green areas, they found something incredible: empty ecological niches. The animals that used to dominate these areas, the desert specialists, were gone or dying. The competition had vanished. It was like walking into a restaurant where every table is empty and you can sit wherever you want. The dinosaurs spread out across Pangaea. They found new food sources, new places to live, new opportunities to diversify. And here's the amazing part. We have direct evidence of this takeover. Fossilized footprints preserved in the rocks. In the Dolomites, in what's now Italy, scientists have found thousands of footprints from this time period. They're laid down over about 3 to 4 million years, spanning the Carnian Pluvial episode. And you can watch the dinosaur takeover happen in real time by looking at these prints. Before the rain started, dinosaur tracks are basically absent. You see prints from all sorts of other creatures, but dinosaurs make up maybe 2% or 3% at most. Then the rain starts, and slowly the ratio changes. More dinosaur tracks appear, they're becoming more common, more numerous. By the end of the Carnian Pluvial episode, dinosaurs are making up over 90% of the fossilized footprints. 90%. That's not just success, that's complete dominance. They went from bit players to running the entire show in just a few million years, all because of rain. If you're feeling sleepy now, that's perfect. Let your mind wander. Picture ancient landscapes, rain falling endlessly, creatures struggling and adapting. Let those images carry you off to sleep. Subscribe if you want more stories like this. And now, let me tell you about one dinosaur in particular that made the most of this opportunity. Chapter 5. The Old World Dies. His name was Herrerasaurus. And he was no joke. 6 meters long, over 300 kilograms, basically the size of a large crocodile but built like a predator, all teeth and claws and muscle. Before the rain started, Herrerasaurus lived in what's now South America, in a place called the Ixigualasto Formation. This was a volcanic floodplain covered in dense jungle, hot, humid, wet. Perfect conditions for this particular dinosaur. Herrerasaurus thrived there. He hunted other reptiles. He competed with early crocodile relatives. He made a living in this steamy environment, but his habitat was limited. The jungle only extended so far inland before giving way to desert. He couldn't expand his range because the conditions weren't right elsewhere. Then the rain started, and everything changed. That warm, humid jungle environment that Herrerasaurus loved. It started spreading, pushing deeper and deeper into the interior of Pangaea. Rain was transforming deserts into his ideal habitat, creating vast new territories where he and his kind could live. So Herrerasaurus and other early dinosaurs started expanding their range. They pushed into areas that had been inhospitable before, and when they got there, they found easy prey. The herbivores that used to dominate were struggling with the new conditions. They were weakened, vulnerable. For a predator like Herrerasaurus, this was paradise. Food everywhere. Little competition from other predators. Space to spread out and hunt. His kind multiplied. They had more offspring. Those offspring survived at higher rates because food was abundant. The population exploded, and Herrerasaurus wasn't alone. Other early dinosaurs were having the same experience across Pangaea. Small plant-eating dinosaurs were moving into newly green areas and finding vegetation everywhere. They ate and grew and reproduced. Other predators followed the herbivores. The whole dinosaur family was expanding. But what about the species that used to run things? The ones that dominated before the rain? They were dying. There were reptiles called Rauisuchians. Before the Carnian, they were the top predators in many ecosystems. Big, powerful, terrifying animals. But Rauisuchians were adapted to drier conditions. They couldn't handle the wet, humid world that was emerging. They struggled. Their populations declined. Eventually, most of them went extinct. Not immediately. It took millions of years, but the trend was clear. They were on their way out. The same thing happened to other groups. Reptiles that had been successful for ages suddenly found themselves outcompeted by dinosaurs in these new environments. It wasn't that dinosaurs were superior in every way. They just happened to be better suited to the conditions created by the Carnian Pluvial episode. Evolution doesn't care about fairness. It only cares about what works in the current environment. And in this new, wetter, warmer Pangea, dinosaurs worked better. The oceans weren't spared either. In fact, marine life got hit even harder than life on land. All that rain had to go somewhere. It flowed across the land, picking up soil and sediment and organic matter. It carved rivers and filled lakes, and eventually it all drained into the ocean. Suddenly the coastal waters were being flooded with fresh water. The salinity dropped. The water became murky with sediment. Nutrient levels spiked from all the organic matter washing in. For marine life that evolved in clear, stable, salty water, this was catastrophic. Coral reefs need specific conditions: clear water for sunlight, stable salinity, specific water chemistry to build their calcium carbonate skeletons. When all those conditions change at once, corals die. And that's exactly what happened. Reef-building organisms took a major hit during the Carnian. Large areas of reef collapsed. The species that depended on those reefs for food and shelter died too, but it got worse. Large areas of the ocean floor became anoxic. That means no oxygen. When you have too much organic matter decomposing in the water, it uses up all the available oxygen. Add in warmer water temperatures, which can hold less dissolved oxygen to begin with, and you get dead zones. Areas where nothing that needs to breathe can survive. These anoxic zones spread across shallow seas and continental shelves, the places where most marine life lived. You can see evidence of this in the rock record. Black shales deposited during the Carnian, indicating oxygen-poor conditions. Fossil assemblages showing mass die-offs. Conodonts, little eel-like creatures with elaborate tooth structures, got hammered. Ammonoids, those beautiful spiral-shelled cephalopods, took major losses. Crinoids, filter-feeding animals that lived attached to the seafloor, struggled as the water got murkier. About 30% of marine species went extinct during the Carnian Pluvial episode. But again, while some groups were dying, others were adapting and thriving. Dinoflagellates, single-celled organisms that are a major component of ocean plankton, did really well. They can handle changing conditions. They benefited from all those nutrients washing into the ocean. As other groups declined, dinoflagellates expanded. The base of the marine food web was being restructured. The whole planet was in upheaval. Old ecosystems were collapsing. New ones were emerging. Species were going extinct and evolving at rates rarely seen in Earth's history. And at the center of it all, powered by 1 million years of rain, dinosaurs were rising. They were spreading across every continent, diversifying into new forms, adapting to different environments. They were becoming the dominant large land animals on Earth, a position they would hold for the next 150 million years. If you're still listening, let your thoughts drift now. Imagine those ancient storms, the rain falling endlessly, the world transforming beneath it. Let those images blur together as you relax deeper, and when you're ready, let me tell you about the footprints, the evidence left behind that tells us this whole incredible story. Chapter 6: Rise of the Forgotten Ones. There's something powerful about footprints. They tell a different story than bones do. Bones tell you what died in a place, what got buried and fossilized. But footprints? Footprints tell you what was alive and active, what was walking around, hunting, migrating, living their lives. In the Dolomites of northern Italy, there's a remarkable sequence of rocks from the Carnian period. Layer after layer of ancient sediment, now turned to stone, and in those layers are thousands of footprints. Scientists have studied these prints carefully. They've identified what made each one. They've counted them. They've tracked how the ratios change over time. And what they found tells an incredible story. In the lowest layers, the ones deposited before the Carnian Pluvial episode, dinosaur footprints are rare. You see tracks from other reptiles everywhere. Early crocodile relatives, various archosaurs, all sorts of creatures making their way across the landscape. Dinosaur tracks, maybe 1 in 50. They're there, but they're minor. Then you move up through the rock layers, into the period when the rain was falling, and the ratio starts to shift. More dinosaur prints appear, still not dominant but increasing. Maybe 1 in 20 now, then 1 in 10. The dinosaur tracks are getting bigger too, more diverse. Different species leaving different prints. The dinosaurs are diversifying. You keep moving up through the layers, through millions of years of deposition, and by the end of the Carnian, by the time the rain has been falling for over 1 million years, dinosaur tracks make up over 90% of all fossilized footprints. 90%. Think about what that means. If you were standing on that landscape at the end of the Carnian and you looked at the mud, 9 out of every 10 tracks you saw would belong to a dinosaur. Everything else had been pushed to the margins, reduced to bit players in a world now dominated by these once insignificant creatures. And this pattern isn't unique to the Dolomites. Scientists have found the same trend in Argentina, in Central Europe, in multiple locations across what was once Pangaea. Everywhere they look, the story is the same. Dinosaurs rising from obscurity to complete dominance in just a few million years. But how did they do it? What made dinosaurs so successful in this new, wet world? Part of it was luck. They happened to be adapted to the right conditions at the right time. But it was more than just luck. Dinosaurs had certain advantages. They were bipedal, walking on 2 legs, which made them faster and more efficient than many 4-legged competitors. They had good eyesight, complex brains for their size. Many had serrated teeth perfect for tearing flesh, strong jaws, sharp claws, but lots of reptiles had those features. What made dinosaurs special? Maybe it was their metabolism. There's some evidence that dinosaurs weren't cold-blooded like modern reptiles, but weren't fully warm-blooded like mammals either. They might have had something in between. This could have given them an advantage in the warm, humid climate of the Carnian. They could be active without needing as much food as a fully warm-blooded animal, but they weren't sluggish like a cold-blooded reptile in cool weather. Or maybe it was their respiratory system. Modern birds, which evolved from dinosaurs, have incredibly efficient lungs. They can extract more oxygen from each breath than mammals can. If early dinosaurs had a similar system, they could have been more active and energetic than their competitors. More stamina for hunting or escaping predators. Or maybe it was something simpler. Maybe they were just adaptable, able to eat different foods, live in different environments, adjust to changing conditions. Whatever the reason, it worked. Dinosaurs succeeded where others failed, and once they got that initial foothold, once they started spreading and diversifying, momentum carried them forward. More dinosaurs meant more evolutionary experimentation, more chances for useful mutations to appear, more opportunities to adapt to specific niches. Some dinosaurs started eating plants exclusively. developing special teeth and digestive systems for processing vegetation. Others became specialized predators, hunting specific prey. Some grew larger, using size as a defense against predators. Others stayed small and quick, relying on speed and agility. The dinosaur family tree was branching rapidly, new species appearing all the time. By the late Triassic, just a few million years after the Carnian, dinosaurs had diversified into most of the major groups we recognize today. There were theropods, the two-legged predators that would eventually include Tyrannosaurus rex and Velociraptor. There were sauropodomorphs, the long-necked herbivores that would become the largest land animals ever. There were ornithischians, the group that would give rise to Stegosaurus and Triceratops and all the armoured and horned dinosaurs. All of these lineages trace back to those early dinosaurs that spread across Pangaea during the Carnian Pluvial episode. The million-year rain had set everything in motion. It had cleared out the old guard and given dinosaurs their chance, and they took that chance and ran with it. For the next 150 million years, dinosaurs would dominate terrestrial ecosystems. They would evolve into thousands of species. They would spread to every continent. They would rule the Earth. And it all started with rain. If your mind is wandering now, that's good. Let it wander. Picture those first dinosaur footprints appearing in the mud. Imagine them spreading, multiplying, filling the landscape. Think about how one event, one geological accident, changed the entire course of life on Earth. Let those thoughts drift. Get comfortable. And if you haven't already, hit that subscribe button so you can find more of these stories when you need them. Now let me tell you about what happened when the rain finally stopped. Chapter 7. Footprints in the mud. After a million years of rain, you'd think the planet would be unrecognizable, and you'd be right. The landscape had been completely reshaped. Rivers flowed where none existed before. Lakes filled valleys that had been bone dry. Wetlands and swamps covered areas that had been desert for millions of years. The vegetation had changed entirely. Dense forests of ferns and conifers replaced the sparse desert plants. New species that loved moisture spread rapidly across Pangaea. And the animal life? Completely reorganized. Dinosaurs were everywhere now. Small ones hunting insects in the undergrowth, medium-sized ones chasing prey through the forests, large ones browsing on high vegetation. They occupied every available ecological niche. Top predators, herbivores, omnivores. They were the new rulers of the planet. But eventually all that rain had to stop. After 4 major pulses, after over 1 million years of continuous precipitation, the weather patterns finally began to normalize. Why? What changed? It comes down to the Wrangelian eruption running out of steam. These flood basalt events are driven by hot plumes from deep in the Earth's mantle, but they're not infinite. Eventually the plume weakens, or shifts position, or the crust moves away from it. Whatever the reason, the magma stops flowing at the same rate, and when the eruption slows, so does the emission of volcanic gases, less carbon dioxide being released, less greenhouse effect. The climate begins to cool slightly, and those coal beds that had been burning for hundreds of thousands of years, they eventually burn themselves out, or the magma stops reaching them and they go dormant. Either way, the rate of greenhouse gas emission starts to decline. It's not a sudden switch, it's gradual. The eruption sputters along for a while, having active periods and quiet periods. But the overall trend is downward, and once emissions start declining, the carbon cycle begins working in reverse. Plants, which have been thriving in the warm, wet environment, are pulling carbon dioxide out of the atmosphere through photosynthesis. They're building it into their tissues, their leaves, their wood, their roots. When they die and get buried, that carbon gets locked away. Over time, some of it turns into coal, the same coal that might burn in a future eruption, or be mined by humans millions of years later. But in the short term, the plants are acting as a carbon sink. They're removing CO2 from the atmosphere faster than it's being added. Atmospheric carbon dioxide levels start to drop. The greenhouse effect weakens. Temperatures begin to decline back toward previous norms. And as temperatures drop, the water cycle slows down. Less evaporation means less atmospheric moisture. Less moisture means fewer clouds. Fewer clouds mean less rain. The mega-monsoons taper off. The rain becomes less intense. Weather patterns start to normalize. The planet is reaching a new equilibrium, but it's not the same equilibrium as before. Too much has changed. The landscape has been physically reshaped. Species have gone extinct. New species have evolved and spread. Ecosystems have been completely reorganized. You can't just go back to how things were. The world has moved forward, and the dinosaurs, they're not giving up their dominant position just because the rain stopped. They've established themselves across Pangaea. They've diversified into multiple ecological roles. They've adapted to a wide range of environments. Some species might struggle as wetlands dry up and forests thin out, but others will adapt to the new conditions. The key point is this: the competition that might have kept dinosaurs in check before the Carnian is gone. Those species went extinct. They're not coming back. Dinosaurs have the dominant position now, and they're not letting go. For the next 150 million years, through the late Triassic, through the entire Jurassic period, through the Cretaceous, dinosaurs will rule. They'll evolve into an incredible variety of forms: tiny feathered dinosaurs and enormous sauropods weighing tens of tons, armored dinosaurs and horned dinosaurs, flying dinosaurs that will eventually become birds. The dinosaur radiation will be one of the most spectacular examples of adaptive radiation in Earth's history. And it all traces back to that rain, to the Carnian Pluvial episode, to one geological event that gave them their opportunity. If the Wrangelian eruption had been bigger, it might have killed everything, including the dinosaurs. If it had been smaller, it might not have caused enough disruption for dinosaurs to gain their advantage. But it was just the right size, just disruptive enough to clear out the old species without destroying everything. The butterfly effect on a planetary scale. One event, one series of eruptions changed everything, and the consequences echoed for hundreds of millions of years. If you're feeling drowsy now, embrace it. Let your thoughts become fuzzy. Imagine those ancient landscapes slowly drying out, dinosaurs spreading across the land, the age of giants beginning. Let it all blur together as you drift off, and tomorrow, if you remember this story, maybe share it with someone who'd enjoy it too. Now let me tell you about the oceans and what was happening beneath the waves during all of this. Chapter 8. The ocean turns to poison. While dinosaurs were taking over the land, the oceans were going through their own transformation. And it wasn't pretty. All that rain falling on Pangaea had to go somewhere. It flowed across the land, carving channels, forming rivers, picking up everything in its path: soil, sediment, organic matter, dissolved minerals, all of it washing into the coastal waters. Imagine being a fish living in a clear, clean ocean. You can see for meters in every direction. The water is pleasantly salty, the right temperature, the right chemistry for your body. And then, suddenly, the water starts changing. It becomes murky, cloudy with suspended sediment. You can barely see a few body lengths ahead. The salinity drops as fresh water pours in from the land. Your body isn't adapted to less salty water. you start having trouble regulating your internal chemistry. The temperature rises, the greenhouse effect is warming the whole planet, and the ocean is absorbing that heat. And then there's the oxygen. The level starts dropping. All that organic matter washing in from the land decomposes in the water, consuming oxygen in the process. You start struggling to breathe. You move to shallower water where there's more oxygen exchange with the atmosphere. But other creatures have the same idea. It's crowded. There's competition for every breath. And the worst part, the water is becoming more acidic. All that carbon dioxide in the atmosphere, the ocean absorbs it. When CO2 dissolves in seawater, it forms carbonic acid. The more CO2, the more acidic the water becomes. This is a huge problem if you're an organism that builds a shell or skeleton out of calcium carbonate. Coral, mollusks, certain types of plankton, some fish. When water becomes acidic, it's harder to extract the calcium carbonate you need. Your shell becomes thinner, weaker. Existing shells can even start to dissolve. It's like trying to build a sandcastle while someone sprays it with a hose. You're fighting chemistry itself. This is what happened during the Carnian Pluvial episode. The ocean became a hostile environment for huge numbers of species. Coral reefs collapsed. These complex ecosystems that supported thousands of species just died. The corals couldn't handle the changing conditions. They bleached and died, and the reefs crumbled. Ammonoids, those beautiful spiral-shelled creatures that had been so successful for millions of years, took major losses. Many species went extinct. Conodonts, crinoids, various types of shellfish all struggled. Many died. About 30% of all marine species went extinct during the Carnian. But as always in evolution, while some species died, others found opportunities. Dinoflagellates, those single-celled organisms, thrived. They're adaptable. They can handle variable conditions, and they loved all those nutrients washing into the ocean. As other species declined, dinoflagellates exploded in population. They became even more important to the marine food web, and there were other changes too. The composition of plankton shifted. New species emerged that were better adapted to the warmer, more acidic water. The marine ecosystem was being rebuilt from the bottom up. In some areas, the seafloor became completely dead, anoxic zones where nothing could survive. These dead zones persisted for thousands of years in some places. You can see evidence of them in the rock record. Black shales deposited during periods when the bottom water had no oxygen, no bioturbation, the mixing of sediment by living creatures, because there were no creatures down there to do the mixing. Just dark, fine-grained sediment slowly accumulating in a lifeless environment. It was rough if you were a marine organism during the Carnian. Many species that had dominated for ages suddenly faced extinction, but the ocean recovered, slowly, over millions of years. New species evolved to fill the empty niches. The ecosystem reorganized itself. By the Jurassic period, the oceans were thriving again. New types of marine reptiles had evolved. Ichthyosaurs, plesiosaurs, marine crocodiles. Fish had diversified into new forms. The marine ecosystem was different from before the Carnian, but it was healthy, functional, full of life. The planet had adapted, the way it always does. Let your mind drift to those ancient oceans now. Imagine swimming through murky water. The struggle of sea creatures trying to survive. The slow recovery as conditions improved. Think about how resilient life is, how it finds a way even in the worst conditions. And if you're getting sleepy, good. That's the goal. Let these images carry you off to sleep. Tomorrow's another day, but tonight, just rest, relax, drift. And let me tell you one more thing about those rivers that formed during the Carnian. Chapter 9. New Rivers, New Life. Before the Carnian Pluvial episode, the interior of Pangaea was mostly endorheic basins. That's a fancy term that means the drainage didn't reach the ocean. Any water that did fall would collect in enclosed depressions. It would form temporary lakes that eventually evaporated, leaving salt flats behind. But when the rain started and kept going for 1 million years, those basins filled up and overflowed. Water found pathways to the sea. It carved channels through the landscape, and rivers formed. Real, permanent rivers connecting the interior to the coasts for the first time in millions of years. These new rivers changed everything. They created highways for species migration. Animals could follow them inland, moving into territories that had been inaccessible before. Plants dispersed their seeds along riverbanks, colonizing new areas. Fish that had been confined to coastal waters could now swim upstream into the interior. The connectivity of Pangaea increased dramatically, and this had huge implications for evolution. Populations that had been isolated could interact again. Gene flow increased. New combinations of traits appeared. The rivers also created new habitats. Riverbanks with different conditions than the surrounding land. Floodplains that were periodically inundated. Deltas where the rivers met the sea. Each of these habitats became home to specialized species. Evolution went into overdrive, and the rivers themselves were powerful forces of erosion. They carved deep valleys through the landscape. They transported vast amounts of sediment from the interior to the coasts. In some places they cut through soft rock, creating dramatic gorges. In other places they meandered across floodplains, depositing fertile soil. The geography of Pangaea was being rewritten, and all of this was driven by water, by rain that fell for 1 million years and had to find its way back to the ocean. Scientists studying the rock record can trace these ancient river systems. They find channel deposits, sand and gravel laid down by flowing water. They find floodplain deposits, fine-grained sediment from when the rivers overtopped their banks. They can reconstruct where the rivers flowed, how big they were, how fast the water moved, and they can see how these rivers created opportunities for life. Dinosaur fossils are often found along ancient river valleys. That's where the animals congregated, near water sources, in the fertile floodplains. The same is true for plant fossils. They're concentrated along what were once riverbanks and lake shores. Water is life. It was true 230 million years ago, and it's true today. Those rivers that formed during the Carnian Pluvial episode, some of them lasted for millions of years. Long after the rain stopped, the drainage patterns remained. The rivers kept flowing, fed by normal rainfall. They became permanent features of the landscape, and life adapted to them. By the Jurassic period, Pangaea had a well-developed river system. Water flowing from the interior to the coasts, fish swimming in those rivers, dinosaurs drinking from them, plants growing along their banks. The world was wetter than it had been before the Carnian, more hospitable to life, more diverse, and dinosaurs were perfectly positioned to take advantage of it all. They spread along those river valleys. They followed the water inland. They established populations in every available habitat. By the end of the Triassic period, dinosaurs had colonized every part of Pangaea. They were the dominant large land animals on every continent. And the stage was set for the Jurassic, the age of giants. If you're still awake, don't worry. Sometimes the mind needs to process these stories before it can fully relax. Just let the words wash over you. Don't try too hard to follow every detail. Picture water flowing, rivers carving through ancient stone, life spreading and diversifying. Let it all blend together into a peaceful flow of images and thoughts, and when you're ready, let me tell you about what came after, about the legacy of the million-year rain. Chapter 10. The storm finally breaks. There's something haunting about the end of the Carnian Pluvial episode. After 1,000,000 years of rain, after the world was completely transformed, the clouds finally broke. The sun came out, not just for a day, but permanently. Weather patterns returned to normal, and life on Earth continued, but in a radically different form than before. The dinosaurs that had spread across Pangaea during the wet period, they didn't disappear when conditions dried out a bit. They'd already established themselves. They'd already outcompeted their rivals. They had the dominant position, and they kept it. Through the late Triassic, they continued to diversify. Some grew enormous. The first sauropods appeared, long-necked giants that could reach vegetation no other animal could access. Other dinosaurs developed armor, plates and spikes to defend against predators. Still others developed elaborate horns and crests, probably for display and species recognition. The theropods, the two-legged predators, became more sophisticated, better senses, faster running speeds, more effective hunting strategies. And then Pangaea started to break apart. The same tectonic forces that had created the supercontinent began to tear it apart. Rifts formed. The Atlantic Ocean began to open. Pangaea split into separate continents. And as the continents drifted apart, the dinosaurs on each one evolved in isolation from each other. This led to even more diversification. Different lineages on different continents, evolving in different directions. By the Jurassic period, dinosaurs had reached incredible diversity. There were dozens of major groups, hundreds of species. They occupied every terrestrial ecological niche. They were the undisputed rulers of the Earth, and they stayed that way for 150 million years. Think about that. 150 million years of dominance. All of recorded human history is only about 5,000 years. Modern humans have only existed for maybe 300,000 years, but dinosaurs ruled for 150 million years. That's success on a scale that's hard to comprehend, and it all started because of rain. Because a volcanic eruption in the right place at the right time created conditions that favored one group of animals over others. One event, one geological accident, changed everything. Of course, nothing lasts forever. About 66 million years ago, another catastrophe struck. An asteroid about 10 kilometers wide slammed into what's now the Yucatan Peninsula in Mexico. The impact was devastating. It triggered earthquakes, tsunamis, and threw so much dust into the atmosphere that it blocked out the sun for years. Plants died without sunlight. Herbivores starved without plants. Predators starved without herbivores. The food chain collapsed. And at the same time, there was another flood-Beelalt eruption happening, the Deccan Traps in India, creating similar conditions to the Wrangelian event: volcanic gases, climate change, environmental stress. The combination was too much. The dinosaurs, except for the bird lineages, went extinct. After 150 million years of success, they were gone. But again, their extinction created opportunities. With the dinosaurs gone, mammals could finally expand. They'd been waiting in the wings the entire Mesozoic, staying mostly small, mostly nocturnal, trying not to get eaten. But now the dinosaurs were gone, and mammals exploded into every available niche. They diversified into the forms we know today: whales, bats, horses, elephants, cats, dogs, bears, primates. And eventually, one lineage of primates evolved larger brains, started making tools, developed language, built civilizations. Us. We're here because the dinosaurs went extinct. We're beneficiaries of that catastrophe, just like dinosaurs benefited from the Carnian. It's humbling when you think about it. Our entire existence traces back through this chain of accidents and extinctions. If the Wrangellian eruption hadn't happened, maybe no dinosaur dominance. If the asteroid hadn't hit, maybe no mammalian radiation. If any of 1,000 events had gone differently, we wouldn't be here. The path from single-celled organisms to modern humans is full of contingencies. Random events that could have changed everything. The Carnian Pluvial episode is just one node in that vast network of causality, but it's a crucial one. It reshaped life in ways that echoed for hundreds of millions of years, and maybe, in some small way, understanding that helps us see our place in the larger story of Earth. We're not separate from nature, we're part of it. We're the latest chapter in a story that's been unfolding for billions of years, a story of change and adaptation, of catastrophe and recovery, of extinction and rebirth. The rain that fell for 1,000,000 years is long gone, but its effects remain, written into the rocks, preserved in fossils, visible in the shape of life itself. And that story continues today. The planet keeps changing, evolution keeps working, new species emerge, old ones fade away. The story isn't over, it's still being written, and we get to be part of it. If you're drifting off now, that's perfect. Let these thoughts dissolve. Let your mind rest. Think about deep time, about the vast scales of Earth's history, about rain falling for longer than you can imagine. Let it all fade into peaceful sleep, and maybe tomorrow you'll remember parts of this story, and maybe you'll look at the world a little differently. Good night, sleep well, and thanks for listening. Chapter 11. The Age That Changed Everything. Before we end, let's zoom out one more time. Let's see the whole picture. 230 million years ago, Earth was a different planet. One supercontinent, harsh deserts in the interior, life clinging to the margins. Then a geological accident happened, a flood basalt eruption in what's now Canada and Alaska. Magma breaking through the crust, coal beds igniting, gases flooding the atmosphere. The climate changed, the water cycle accelerated, rain started falling, and kept falling. For over 1,000,000 years, the landscape transformed. Deserts became wetlands, wetlands became forests, rivers carved through the land, lakes filled dry basins, ecosystems collapsed and reformed, old species died out, new species emerged, and dinosaurs, small and insignificant before, found themselves in paradise, their ideal habitat spreading across the entire continent. They expanded, diversified, dominated, and they held that dominance for 150 million years, longer than any other group of large land animals before or since, all because of rain. It's a reminder that Earth is a dynamic system, that everything is connected, that small changes can have enormous consequences. The carbon cycle drives, the water cycle drives, the climate drives, evolution drives the composition of life itself. When you perturb one part of the system, everything else responds. We're seeing that today. We're pumping greenhouse gases into the atmosphere, changing the climate, affecting weather patterns, stressing ecosystems. The mechanisms are the same as during the Carnian. Carbon dioxide trapping heat, water cycle accelerating, conditions changing faster than many species can adapt. The difference is the timescale. The Wrangellian eruption released its carbon over 1,000,000 years. We're doing comparable things in just a couple of centuries. That's what makes it dangerous. Evolution needs time to work. Ecosystems need time to reorganize. When change happens too fast, there's no time to adapt. But the Carnian also teaches us that life is resilient. The planet recovered, new ecosystems emerged, biodiversity rebounded. Given enough time, Earth heals itself. The question for us is whether we can adapt to the changes we're causing, whether the systems we depend on will remain stable enough to support human civilization. The planet will be fine in the long run. Life will continue. New species will evolve. But will we be around to see it? That's less certain. These are the questions raised by studying events like the Carnian Pluvial episode. Not just abstract geological curiosity, but insights into how our own world works, how systems interact, how changes cascade, how life responds to upheaval. The rain that fell for 1 million years changed everything. It set the stage for the age of dinosaurs, which eventually led to the age of mammals, which eventually led to us. We're part of that story, the latest chapter in an epic that's been unfolding for billions of years. And the story continues. The planet keeps changing, life keeps evolving, new chapters keep being written. We just happen to be here for this one. As you drift off to sleep tonight, think about that, about the vast scales of time, the incredible history of this planet, the chain of events that led to your existence. Think about rain falling for 1 million years, about dinosaurs rising from nothing to rule the world, about continents drifting and climates changing and life adapting. Let it all wash over you. Let your thoughts dissolve into peaceful rest. You're part of something much larger than yourself, part of the story of Earth, part of the ongoing dance of life and environment and change, and that's a pretty amazing thing to be part of. So rest now, let go, drift into sleep. The story will still be here tomorrow, and the day after, and the day after that. But tonight, just rest. Sleep well, wherever you are. Boston, Berlin, Mumbai, Melbourne. Wherever you're listening from, thanks for being here. And if you want more stories like this, subscribe. Leave a comment telling me where you are and what time it is. I love hearing from people all over the world. Until next time, good night.